Good morning, students. Today we are going to discuss the topic projection of planes. This is part of the subject engineering graphics, which is there for mechanical engineering students in 1-1, and some of the branches will be having this subject in 1-2 as well. Okay, so let us dive into this topic, very interesting topic. So first of all, let us know what is meant by a plane. A plane is a two-dimensional object which is having length and breadth only. So here we are assuming that the thickness is almost nil, or which is neglected. If at all any slight thickness is also there, which is neglected. There are various shapes of plane figures which are considered in the engineering drawing practice or engineering graphics practice. Some of the commonly used shapes are your square, rectangle, circle, pentagon, hexagon, etc. I'll show you all these shapes here. So you all know how to draw square, rectangle, triangle, circle, trapezoid, all these things you all know. And before going into these things, for drawing your pentagon and hexagon, you should be knowing the angle between the sides. So if at all you know the angle, then it is fine. If at all you don't know the angle, you can calculate the total angle. Suppose you consider a pentagon or you consider a hexagon, you can calculate the total angle by using a very small formula, which is given by 180 into n minus 2. Okay, so this gives the total angle of the polygon. So if at all, let us consider the very basic polygon, that is triangle. So for the triangle, n is equal to, what is the n is equal to number of sides, that is 3 for a triangle. Therefore the total angle becomes 180 minus 3 minus 2. Okay, so that gives me 1 here, sorry, 180 into, this is into here, 180 into 3 minus 2, so this gives me 180 into 1, that is 180. So this is the total angle, this is the total angle in a sum of angles in a triangle, not the total angle, this is the sum of angles in a triangle. For a pentagon, n value becomes 5 here, so that becomes 180 into 5 minus 2, so that is 180 into 3, that gives me 540 degrees. And each angle would be giving me 540 by the number of sides, that is 5. So each angle in a pentagon would be 108 degrees. So if at all hexagon is given for you in your examination, and by chance you don't know how to calculate each angle, or you forgot how to calculate each angle, then what you have to do is you have to use this formula 180 into n minus 2, that is 180 multiplied by number of sides. For a hexagon the number of sides are 6, so 6 minus 2, so 180 into 4, that will be equal to 720 degrees. So that is the sum of all internal angles for the hexagon. And now for each angle how much it would be, that would be the total angles, total sum of angles, that is 720 divided by the total angles, that will be always equal to the number of sides. So how much it comes to, 720 by 6, that is equal to 120 degrees. So in that way you have to calculate and you have to draw the polygon, given polygon. Most of the times you will be encountering a square, a rectangle, or a pentagon or a hexagon. In some scenarios you will be getting a circle, but most of the times you will be getting a pentagon or a hexagon. Let us assume that your paper will almost be getting, you will be getting a pentagon and a hexagon, or a hexagon, whatever it is. Okay, I hope I am clear on this slide. You have to remember this formula 180 into n minus 2. This gives the sum of all internal angles of a polygon. Let us go to the next slide. And one more important thing while you are drawing is that you have to read the question very carefully, and if at all in your question there is a term that is mentioned as side edge on HP or side edge on VP, then you have to draw the polygon like this. That means the triangle can be drawn in different ways. I'll show you how to draw. The triangle can be drawn like this also. Okay, the triangle can be drawn, maybe I have to clear this. Okay, I'll erase this one. The triangle may be drawn like this also, okay, and the triangle may be drawn like this as well, and also the triangle may be drawn like this. So these are the different shapes of a triangle that are possible for you to draw. So whenever you are given in the question that there is a side or edge lying on HP or lying on VP, and whenever you see this term side slash edge, you fix in your mind that one of these sides will be towards your left hand side, and it will be vertical or perpendicular to the XY line. It can be below the XY line if at all it is given to HP, and it can be above the XY line if at all it is lying on the VP. Whatever it is, but side and edge, that refers to the position of your triangle or your rectangle or square or your pentagon or your hexagon. One of these sides will be perpendicular to XY, and that side will be perpendicular and towards your left hand side. That means you will start with that side and then construct the other diagram. Okay, so whenever in your question it is given as side and edge, you straight away you can understand that this is not a option for you. Okay, and this is also not an option for you. Okay, because it is given as side, this is the right option for you. Okay, and if at all, sometimes what happens is that in your question they will give corner. Okay, you find the term corner in your question, then this should be the position of your diagram. So you can see here, when it is mentioned as a corner in your question, the triangle has started with this corner here, and your rectangle or square has started with this one, and your pentagon has started with the corner here, and your hexagon also has started with the corner. Whereas this refers to side and edge position. This refers to side and edge position. Okay, side and edge position. First of all, we are drawing the side, and where we are drawing that side, we are drawing that side towards the left of us. Okay, you're in front of the drawing sheet, you will draw the side first towards your left hand side, and from there you will start the construction. Okay, this is one very very important point, without understanding which you will not be able to solve any problem. Okay, now let us see how to solve one of the problems which may be complicated problem, we'll see, which is inclined to both the planes. Okay, so step 1, for solving the problem, we are going to assume that suitable conditions and draw the front view and top view of initial position. How we are going to do that, I'll tell you in the next coming step 2. Consider the surface inclination and draw the second front view and top view. And step 3, after consider the side edge inclination and draw the third and final front view and top view. So your total problem will be solved in 3 different steps. Position 1, which will be the initial position. Position 2 will be drawn by considering the surface inclinations, and position 3 will be drawn by considering the side or edge considerations. So in your question, while reading the question itself, you have to understand that you will not be doing the side edge inclination initially, but you will be doing the surface inclination initially. Although if at all in the question it is given later to your side edge inclination to confuse you, do not get confused and just draw it in the same sequence. First of all, you will be finalizing the initial front view and top view, then you will go for the surface inclination, and then you will go for the side inclination. Okay, so let us see how we are going to finalize the initial position, that is the initial front view and top. If at all we are doing it right, our problem will be right. If at all we are getting this portion, that is step 1, wrong, the remaining 2 steps, although we do it perfectly, these 2 will be dependent on the first step, so everything will go wrong. Let us see how to do that. Okay, assumptions for initial position. Initial position means assuming the surface either parallel to horizontal plane or your vertical plane. How we are going to do this is that, if at all in the problem it is given that the surface is inclined to HP. Okay, understand this thing very clearly. Please read the question carefully and understand and underline these points. If at all in the problem surface is inclined to HP, assume it to be parallel to HP for your step 1. Okay, And if at all the surface is inclined to your vertical plane, assume it to be parallel to vertical plane. So this is what we have to do. And if the surface is assumed parallel to horizontal plane, then what will happen? Its true shape will be seen in the top view. You all know this. You have seen the projection of points as well as projection of straight lines, so I need not explain the whole concept again. If at all a surface is assumed, something is assumed to be parallel, or if at all assumed to be parallel to a certain plane, its true shape will be seen in that certain plane. Okay. And similarly, if surface is assumed to be parallel to your vertical plane, its front view will show the true shape. Its true shape is seen in the vertical plane. Okay. Hence, first what we are going to do is that we are going to draw that shape. Let us look into a problem here. The problem is given as like this. There is a rectangle 30 mm and 50 mm sides. These are the dimensions of the sides of the rectangle, and is resting on horizontal plane on one small side. So here important thing is that the side is the important keyword here, which gives you an idea of how the position of the plane will be. This side is inclined at 30 degrees to the VP. So you can see in the question that the side inclination is given as 30 degrees, and one more important inclination that will be given, that is surface inclination is 45 degrees to the horizontal plane. So these are the important things. These are the important things. Whatever I have underlined here, it is resting on the horizontal plane on one of its small sides, and this small side is inclined 30 degrees to the vertical plane, and also the surface of the plane makes an inclination of 45 degrees with the horizontal plane. So first and foremost important thing that is, you have to identify surface inclination. Surface is inclined to horizontal plane, therefore we are going to assume that your plane is parallel to horizontal plane. That is the assumption that we are going to do in order to draw the true shape in the step 1. So that is what I am going to do first. I am going to assume that the plane is parallel to my horizontal plane. When the plane is parallel to my horizontal plane, its true shape is seen in the top view. Therefore what will happen? The true shape will be coming below the xy line, because horizontal plane lies below the xy line and vertical plane lies above the xy line. And as I mentioned previously, side is given, not a corner. Side is given. That means you are going to draw one of the sides of the rectangle perpendicular to the xy line, and where you are going to start this side? Towards your left. Okay, you are going to draw a vertical line, and then you are going to mark the rectangle on that vertical line, and this line is perpendicular to xy, and this line will be starting towards your left hand side. I'll show you how to do it. Okay, so first of all we'll draw the xy line. This is the reference line here, and then I have started the rectangle like this. I have started with one of its sides perpendicular, because side is given here, one of its side is perpendicular to xy, and because we assume that this plane is parallel to HP, what I have done is that I have drawn this one below the xy line. Okay, so I'm going to name it, and also in the question it is given that small side is resting. He has mentioned specifically the small side, so I have drawn the 30 mm side first and then the 50 mm side like this horizontally. I hope you got it. I'm going to name it A, B, C and D, because it is the top view. I'm going to name it as small a, small b, small c, small d. There are no dashes here. Please observe, this is the important thing that you have to note. The notation is very, very important. Although your problem might be right, if at all you put wrong notation, the evaluator might not give you marks. So please always see that you follow the proper notation. Always your top views will be without the dashes, and your front view will be with the dashes. I'm going to project the projections of the points A, B, C and D, and then I'm going to mark the true length, that is A dash, B dash, C dash, D dash. This completes my step 1. I have drawn the true shape which is in the top view, and I have drawn the true length which is in the front view. Next I am going to do the surface inclination. So in the question, to confuse you, what he has done is that he has first mentioned the side inclination 30 degrees to vertical plane. but always remember this point. You have to incline the surface before the side, and then last step would be the side inclination. So initial step will be the true shape, second step will be the surface inclination, and third step will be the side inclination. The order given in the question might be anything. He can mention the side inclination initially, and then the other conditions might be given at the last, but still always please follow these things. First step is to draw the true shape, second step is to make the surface inclination, and third step is to make the side inclination. Okay, so let us do the surface inclination. That means I'm going to incline a dash, b dash, c dash, d dash by an angle of, what is the angle given here, 45 degrees. Okay, 45 degrees to HP. Therefore my inclination will be above the xy line. So that is my line that I have drawn here above xy line, and this inclination is of 45 degrees. I'm going to transfer these points a dash, b dash, c dash and d dash onto this line like this: a dash, b dash, this is my c dash and d dash, and then I'm going to draw the projection lines from these points to down, that is onto my horizontal plane. Okay, like that, and correspondingly I'm going to draw projection lines from the initial true shape rectangle. So this gives me my new rectangle, that is A1, B1, C1 and D1. If at all you can observe, there is a difference in the shape between the true shape and the shape obtained after the inclination. There is a considerable reduction in the dimension because of the inclination of the surface. Because it is horizontal here, you can see the complete true shape. Also the first step says that we are assuming it parallel, therefore we can get the exact true shape. But whenever a surface is inclined, its true shape is not obtained. There will be a diminishing or reduction in the shape of the plane dimensions. So that is what we got here: A1, B1, C1 and D1. Okay, so second step is also over. I am just left with my third step, which is to be done. For third step, side inclination, I have to do the side inclination. In the question, small side is inclined at 30 degrees to the vertical plane. So what I'm going to do is that I'm going to draw a line at 30 degrees to the xy below the xy. Inclinations to the horizontal plane are above the xy line, and inclinations to the vertical plane are below the xy line. You all know this already. I need not tell you why and how. So I'm going to draw a line here at 30 degrees angle to xy below the xy line, and then I'm going to transfer the side. Which side I'm going to transfer? This AB or A1B? Please always make sure that you're going to transfer this A1B1 to the next step, because this step is the first step, this is the second step, and this is the third step. Third step is linked to your second step, not the first step. So sometimes there are chances that people might transfer different dimensions. Here in this case both these things are same, but still I am letting you know that always transfer whatever dimensions are obtained in your second step to the third step. Okay, so that is the line which is at 30 degrees inclination. I'm going to mark the angle, yeah, 30 degrees inclination, and then I have transferred the side. What I have done, I have marked A1, and then with compass I have marked B1, and then I have recreated the other rectangle, that is A1, B1, C1 and D1. Okay, I haven't drawn A, B, C, D here, so this is one important thing that you have to make a note of. A1, B1, C1, D1, this whatever dimensions are obtained in the second step, I have transferred those into the third step. Now it's very simple. I am going to draw the projection lines from A1, B1, C1, D1 towards the vertical plane, and then correspondingly horizontal projection lines from this A dash, B dash, C dash, D dash, and wherever those things are going to intersect, that is A dash line intersects with A1 line, I am going to mark that point as A1 dash. B dash line intersecting with B1, I am going to mark it as B1 dash. This is how I am going to do it. I have drawn lines and the horizontal lines, and then I am naming these intersection points. Okay, so this is the point where uh, okay, this is the point where A1 projection line from A1 and projection line from A dash are intersecting. I have named this as A1 dash. Okay, and this is the point where projection line from C1 and projection line from C dash are intersecting. I have marked it as C1 dash, and I'm joining all these things, and this is my final answer: A1 dash, B1 dash, C1 dash, D1 dash. So your total problem is done in 3 steps. First step is the true shape, second step is the surface inclination, and third step is the side inclination. I hope you understood the problem. Thank you.